My name is Kami Beverly, and this is my Math Center for Mathematics Methods course. In this center, I chose to cover the Math Common Core Standard 3A, which is understand fractions as equivalents or equals if they are the same size or the same point on a number line. Also, they need to explain the equivalence of fractions in special cases and compare fractions by reasoning about their size. And the final standard is recognize and generate simple equivalent fractions. For example, 1/2 equals 2/4, 4/6 equals 2/3, and they need to explain why the fractions are equivalent by using a fraction model. So for this, I chose to use the Cuisenaire fraction tower rods. I have the 1/2, thirds, fourths, fifths, sixths, eighths, tenths, and twelfths models. Students will also need to use a pencil, have an activity sheet, and they may also use a ruler if they would like help drawing their models. In this assignment, students will use the activity sheet as a guide as they use fractions as models and comparisons. They'll be comparing equivalent fractions, designing equivalent fractions, and comparing fractions to see which is greater, lesser, and ordering a set of fractions from greatest to least and least to greatest. As I worked through this, I realized it took about 15 to 20 minutes for me to work through the problems on my own sheet over here and draw the models. I chose to draw the models vertically and also horizontally based on where they fit best. So I start off by asking for students to model 6 ways to represent 1/2 so they can understand equivalency. So they need to take the 1/2 rod and compare it to other fractions to see which is equivalent. So 1/2 is not equal to 2/3, but it is equal to 2/4. So then they would use 2/4. Then they would keep on comparing. Not 3/5, but it is equal to 3/6. So they would use the 3/6. They would also move on to looking at 4/8, 5/10, and 6/12. They would compare all of these and realize that they are all the same size. They would fill in on their number 1 that 1/2 is also equal to 2/4, 3/6, 4/8, 5/10, and 6/12, which makes there 6 ways to represent. So they would draw and represent with the models. Next, they would move on to modeling fractions and deciding which fraction was bigger. So in this one, they model 5/6. They take the 6th manipulatives. So we're looking at 5/6. And we're looking at 2/3. So they can compare these to see which one is bigger. I also ask comprehension questions on each one of them. How do you know? How do you know which one is bigger? They will be able to see this one is taller than this one. So therefore they will be able to see that 5/6 is greater than 2/3. Then we move on to using 1/2, 5/8, 2/5, and 1/4. They'll need to draw models of them and order them from heights. They will explain how they knew. Additionally, they will move on to using fraction cubes to model 3/4. I asked them to use their dark blue cubes, 1/8 cubes, to create a fraction that's equal to 3/4. I'm asking them to tell how many dark blue cubes they used and what that fraction is. And they will need to reduce and explain how they knew that those fractions were equal. Then moving on, they look at other fractions that are equal and compare them and fractions that are greater or less than. I chose to use this fraction because when I was in school, ordering fractions was often difficult for me because I did not understand why one fraction was greater than the other and I could not represent. So with this station, it gives students a visual representation of why certain fractions are larger than other fractions and how they are equivalent. Thank you.